Can I just choose any vase for my project?
That's fine with me. By the way, how many vases do you need?
Only one for my project, but I want to add one more. Once my work is returned, I could put both vases in my room.
Planning to decorate your own room? No problem.
That looks nice.
Thought so. Do you like it?
How much is it?
Let's see. 150, I think.
But it is too expensive for a school project.
How much is your budget anyway?
I am thinking of spending 100 pesos only for one vase. Then I could use my savings for the other vase.
Then let's look for a smaller one. It should be cheaper, of course. Alright, you can choose now.
Is it okay if I take both?
That's nice.
The vases are beautiful, aren't they? What observation can you make about them?
They all look the same to me, except for the prices maybe.
But the prices are different because of their sizes.
Yes, the two vases are similar in appearance, except for their sizes.
I'm glad you used the word similar, Elizabeth. That is exactly what I intend to discuss with you in class today.
Sounds easy for me. Similarity for me means being the same.
Well, we are going to define the word similarity in the context of geometry.
Huh? Polygons and triangles again?
Yes, exciting, huh?
Those are pentagons, two of which are of the same shape.
That is right. In fact, we can say that polygons A and C are similar.
Hey! But all of them are pentagons anyway. Aren't all of them similar?
What do you think, Gabez?
Well, all of them have 5 sides, but it is obvious that figure B does not have the same shape as figures A and C.
Correct. Let us examine the interior angles of these figures. Lisbeth, can you analyze figure A?
Since each of the sides of figure A is 2, then this kind of polygon is a regular polygon, and so its interior angles have the same measure and therefore congruent.
Yeah, but the same thing can also be said about figure C.
And what do we know about the sum of the interior angles of a convex polygon, Paolo?
We have a formula for that. If a convex polygon has n sides, then the sum of its interior angles is equal to quantity n minus 2 times 180 degrees.
Very good. Let us go back to figures A and C then. Lisbeth and Denise noticed that these two polygons have equal angles. Gabez, could you compute the measure of each angle in these two figures?
Okay, pentagons have 5 sides, so that the sum of their interior angles is quantity 5 minus 2 times 180 degrees equals 540 degrees. Since there are 5 equal angles, then each angle must have a measure of 540 degrees divided by 5 equals 108 degrees. Therefore, each of the angles in figures A and C is 108 degrees.
Correct. We have seen that figures A and C have the same shape. How do they differ then?
One is smaller than the other, so they differ in size.
That is right. But then we need to be accurate too. How different these sizes can be. What about you, Paolo? Is there a way we can describe the difference in size of similar polygons?
I think it's safe to say that the two similar figures are proportional in size. One can be a smaller copy of the other.
Very good. Can we now identify the important features of similar polygons?
I think we see 2 characteristics of similar polygons. Number 1, they must have congruent angles. And number 2, they must be proportional in size.
You're right about that, Gabez. Let us now give the formal definition of similar polygons. figures A and C, we have already shown the equality between the corresponding angles of these polygons. Denise, can you check whether these two figures satisfy the second condition given in the definition?
Yes, ma'am. We need to check whether the corresponding sides of the two polygons are proportional. This means that we should be able to get the same constant whenever we get the ratios of the corresponding sides of the two pentagons.
That is pretty obvious in those figures, I think. In fact, the ratio of each pair of corresponding sides is 2:1. That should prove that figures A and C are indeed similar.
Yes, that is true. We have seen that the corresponding angles of the two polygons are equal, and the corresponding sides are proportional. Thus, we can say that the two polygons are similar. Now, Joyce, you raised a question a while ago. Could you now answer your own question based on the definition of similar polygons?
Alright, it looks to me that the angles of figure B are not all equal, unlike those of figure A and C. So if I compare figures A and B, then they can't be said to be similar since their corresponding angles are not equal. This means that only figures A and C are similar.
That's correct, Joyce.
What about the sides? Aren't we going to check whether they are proportional?
What do you think, Denise?
The ratios of the corresponding sides are different. For example, if we take the bases of figures A and B, whose lengths are 2 and 3 respectively, then we get the ratio 2:3 or 2/3. And then take the upper right sides of the two figures, we get the ratio 2:2 or 1. This tells us that some corresponding sides of figures A and B are not proportional. Well, we get the same conclusion. Figures A and B are not similar indeed.
I think that we need not check for proportionality of the corresponding sides since, in the definition, two conditions are required. First, the corresponding angles are equal. Second, the corresponding sides are proportional. We have already seen that corresponding angles are not equal, and so that will suffice for us to conclude that the two figures are not similar.
You're right, Lisbeth. Let us examine more figures and see if we can easily identify polygons that are similar.
We focus on the shape and size. Okay. Only figures 1 and 2 are similar. Am I right, ma'am?
You're right about the similarity of triangles 1 and 2, Joyce. But look more closely. You must be able to see more than one pair of similar polygons.
Surely, polygons 3 and 6 are right triangles. But they are not of the same shape, right? So they can't be similar.
What about figures 4 and 5? They look like congruent figures to me. Same shape and same size. They are not similar because they are congruent.
Does the definition tell us that the sizes of the similar polygons can't be the same?
I think there is no such condition. We just require equal corresponding angles and proportional corresponding sides.
That is right. In fact, the constant ratio of corresponding sides can be any positive number, so that if this constant ratio is 1, then we can say that the two polygons are of the same size too.
So, are any two congruent polygons also similar? Oh, I see. So in that given set, there are two pairs of similar polygons, 1 and 2, and then 4 and 5.
Yes. Alright, Paolo. You seldom talk in this class, but I am sure you've been listening, right? Could you now summarize what we've just discussed?
Ma'am, I have learned that two polygons are similar if 1. Their corresponding angles are equal, and 2. Their corresponding sides are proportional. So, by just looking at the shapes and sizes of any two polygons, you can easily determine if they're similar or not. Similar polygons need to have the same shape, but they may differ in size.
Can I give another statement?
That is fine. Go on.
Any two congruent polygons are similar, but some similar polygons may not be congruent, and this happens if they are of different sizes.
Well said.